Hello, good afternoon. I will present the survival data analysis project about the analysis of the survival time in lung cancer patient post-surgical. So first, let's try to do a revision of our first homework. We try to fix some minor mistakes. First, we review all the dependencies possible between all the categorical variables between the cipher levels and the other categorical variables. The only one that was accomplished the dependency was TNM. Also, because we have a small sample size and try to avoid low numbers of countings of events in each cells, we decide to collapse the TNM to 5 levels to 3 levels. So, and we double check the dependency. The dependency was still significant with the chi-square test. And then we decide to do the log-rank test for trend, and also significant for the strata TNM, very similar to the TNM not collapsed. So we decide that TNM is already a confounder for CIFRA to be able to differentiate different survival times with the CIFRA and TNM as a strata. So now, taking this in mind, we will do a revision or a comparison with this previous model and the proportional hazard model that we have to make to fit for this homework. So now we can see that in the Cox model, the proportional hazard model assumption, it takes into account that the covariate, it will not influence the hazard function. It will not change in time. It will not change in time in relationship with the covariate. So this model proposed that the effect, the explanation of this covariate is fixed in time. So we need first to check this assumption to be able to do an interpretation of the estimate. So first, we have a exploratory data analysis, and we can see a log minus log survival time, and we can see still we have some messiness in the plot, but we can still see that we have like three trends. One is diagonal, and the other is more flat. Diagonal is related with more advanced stage of the disease. And the one that stay more stable are stage of the disease that are indeed more stable, less risky. So we can still see a trend of parallel line, but of course the line are crossing. So it may be that proportional hazard may be not attainable, maybe not possible to sustain. So. But we have a formal test, the Schoenfeld test with the residual, and also we can see the plot of the Schoenfeld residuals, and we saw that for the global Schoenfeld test, we have a significant a rejection of the we have to accept the null hypothesis. The null hypothesis here is that we are assuming a proportional hazard. This is a good net of fitness, so it is usually sometimes people get confused to do interpretation. But as you see, the value is very marginal. So we can see that we can say that proportional hazard is assumed here. We can assume it here, but it's a very marginal result, and it's more or less is related with what we can see in the plot. So also we can see the Schoenfeld residual trend for two levels of the cipher, and we can see that the line is mostly horizontal, and also the confidence interval band, it allows to see the possibility to include a almost horizontal line. So it's also indeed in line with what we can see in the formal test. And for the good net of fitness, the deviance residual test is we can see that the trend is more or less around zero. That is what we expected. Also, we can see that in the axis of X, the values presents a difference, mostly due to the symmetry of the values of independent covariates that is applied automatically by R. So, and now we can do an interpretation because it's safe, the assumptions are accomplished. So we can do an estimation of the proportional hazard model. So we can see that in comparing to the low, that is our reference group, low cipher level, we can see that medium have 5.5 more times that about to increase the speed of the survival rate, to increase the rate of the survival. So 5.45 more time more risky for medium, and 11 times more risky for high levels of cipher. And of course, all are significant. As a summary, we can try to compare both approach, the log-rank trend and the pH model, and we can see a significant order result in both methods. In the proportional hazard model, we can see a trend also for log-rank, of course, and higher the cipher level is more the risk. Interesting for the proportional hazard model that we can have a magnitude for this increase of the rate of the survival rate time. So, and also we know that for the score test that follow a chi-square, 1 degree of freedom in the proportional hazard model with a single categorical covariate is almost identical to the log-rank test according to this author. So in this case, we don't have 1 degree of freedom, we have 2, because the categorical variable has 3 levels. And so of course we can check if there is some connection, and of course we have that. The score test for the proportional hazard model has a very high value and very low p-value, and for the zeta score log-rank trend we have also a very not so high, but the magnitude of the p-value is still on the same level. So we can see that indeed we don't have 1 degree of freedom, but we have a very similar result and very similar conclusion. We have a trend, we have an order, and we have even the same magnitude for the p-value. So thank you for your attention.